Hello, this is Mrs. Snook with Part 2 of Section 1.3. Part A focused on continuous functions, and Part B is going to focus on what we call piecewise functions. Our objectives is to identify and graph step functions, which are going to be an example of a piecewise function. And we're also going to identify even versus odd functions. So step functions, even and odd. Those are objectives for today's video. First up is the step function, also called the greatest integer function. Take a look at this graph here. And what I want you to notice is that between each pair of integers, it's constant. So starts at -3, goes to -2, but stops there. It then jumps up. So once it's at its next integer, in this case -2, it jumps up there and it's constant until it gets to -1, and then it jumps up. I really like the way it describes it here, constant between each pair of consecutive integers. So I'm just going to remind you of that. And it jumps vertically one each unit at a time. So it's not all connected together. Each one is a piece. That's why it's called piecewise. So, and want to also point out that the symbol used for this greatest integer function is the x with those two brackets next to it. Like this. All right, the first one we're going to do is defined as a piecewise function. There's two functions here. You have the first one, 2x plus 3, and that's defined for where x is less than or equal to 1. And the second one is -x plus 4, and that's defined where x is greater than 1. So the boundary between these two pieces is 1. So what I'm going to do is I'm going to calculate the value of x at the boundary. So from part 1, we have 2 times 1 plus 3, that equals 5. So I'm going to have a point at 1, 5. So 1, 1, 2, 3, 4, 5. Put that there. And then from part 2, we're going to put in 1 for the boundary there. -1 plus 4 equals 3. So now we're going to have a point at 1, 4. And notice this one is going to be an open circle, and this one is closed. And the reason for it is right here. You're less than or equal to 1. That tells you to use a closed circle, whereas that one is open. So on my graph, I've got my closed circle and an open circle. So I've got 1 point on each piece. 2x plus 3 is a line. It's linear. Slope is 2. So to get another point, I'm going to use the slope. It's less than 1. So I'm not going to go to the right. I'm going to go this way. So to get a +2 slope, 1, 2, over 1. There's my other piece. Let me see if I can get a ruler. I don't seem to have a ruler on mine here. So this graph looks like this. Down 2, over 1, down 2, over 1. I'm giving myself a bunch of points just to make it easier for me to sketch, since I don't have a ruler. So that's the first graph. This is number 1. Number 2, I'm going to change colors for number 2. Number 2 is where x is greater than 1. So I'm going to move in the greater than direction, and its slope is -1, so I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. And that goes that way. So that's how I graph the piece line. Just graph your, piecewise. Just find your boundary point. In this case, there was more than one. Check for open and closed circles. And then graph each section. Okay. Now you try this one. So what I want you to do is graph this on your own, and pause your video while you do that. And then when you come back, you can compare your graph to mine. So pause your video now. So do your graphs look like mine? First thing I did is I found the boundary. That boundary happens at 4, at x equals 4. So I plug in 4, and I get 4, -1 for graph 1. The slope of this one is a -1, so I make sure it's going downhill. And I just plotted a couple of points on there to make it easier for me to graph. 2-point minimum, the 1 point at the boundary, and then 1 more point for a line. Graph 2 is also a line. Plug in the 4, I get 0, so I have a point at 4, 0. That one's open, and then slope is +1, so up 1 over 1, up 1 over 1. Right, our next idea is even and odd functions. An even function means that it's symmetric to the y-axis. So if you look at this picture, here's the y-axis right here, and it's a mirror image on both sides. And if you look at the points, an easy way to check is, do you see how they both have the same y? So they're the same vertical height above the x-axis, but one has +x and one has -x. And so that's how you're going to be able to tell an even function. Just make sure it's got a mirror image around that y-axis. Odd function is going to be symmetric not to an axis, but to the origin. Right here is where it's symmetric to. So if you fold it over the origin, these two pieces would land on top of each other. And here's how you can check your points. Notice you have an x and a -x there. And then you have a y and a -y. So what you're looking for there is your points, both the x and the y coordinates, are opposites of each other. Last thing to look at is, what if it's symmetric about the x-axis? That's not a function. Check it out. Vertical line test. Right through here. So not a function. So watch out for that. Even though it might be symmetrical to the x-axis, that's not an even or an odd function. It's not a function at all. All right, so let's take a look at these graphs, and we're going to determine if these functions are even, odd, or neither. So take a look at our first one. Here's the y-axis, and that is symmetrical about the y-axis. So therefore, this one is even. Is it symmetrical about y? Let's take a look at B. Right, there's the origin. Symmetrical about the origin. So that one is odd. Take a look at C. Here's its line of symmetry right there. That's not on the y-axis. So this one's a neither. Last one. Right here is our line of symmetry. So that one is even. Now we're going to do the same thing. We're going to test for even and odd functions algebraically. So this is for people that don't like to look at graphs and you prefer to work things out algebraically. Here's the test for it. If it's even, then what you're going to do is when you plug in a negative x into f of x, you're going to get the same function that you originally had. So plug in negative x. Get original function. If it's odd, when you plug in that negative x, you're going to get -1 times your original function. So plug in negative x, get -1 times your original function. And that's what this notation means. So you see right here, that negative in front, that's going to be a -1 times your original function. So let's do some of these so that we can see how that works. So I'm going to plug in for g of x, I'm going to plug in a negative x, I'm going to do g of negative x, and I get a negative x cubed minus negative x. So negative x cubed, it's just going to give me that, because I'm going to have x times x times x, there's my x cubed, negative times negative times negative. That's an odd number of negatives, so your answer is going to be negative. And then minus a negative x is a plus x. So that's my g of negative x. Now compare my original g of x equals x cubed minus x. Now those don't match, so it's not an even function. Now let's see if it's odd. And what I'm going to do is I'm just going to do a negative g of x. So I'm going to multiply by -1. And those match. So therefore this one is odd. That's all there is to it. Now let's plug in -1 into h of x. I'm going to do h of x over here. So h of negative x equals negative x squared plus 1. Negative x times negative x is a positive x squared. I have x times x, which gives me x squared. And then a negative times a negative, that's a positive. So I have a positive x squared plus 1. That's h of negative x. Compare that to my original h of x. I'm just going to write that down here. H of x was given to us as x squared plus 1. These are the same. Therefore, this one is even. All right, now I'm going to do C. I'm going to do f of x. Plug in a negative x cubed minus 1. Compare, not the same because of the negative in front. And f of x equals x cubed minus 1. So not the same. Now let's multiply f of x by -1 and compare that. So negative f of x is going to be negative x cubed plus 1. Also not the same because of this plus. So this one is a neither. Okay. And that's it for today's lesson. Thank you for watching. Have a great day.